Unified dumbass here. How the hell are we going to combine quantum mechanics with general relativity? Here's my mechanical perspective on desitter boundaries. When I was working in the factory, I noticed that the coils that I was looking at was analogous to entanglement. In quantum mechanics, the entanglement system is symmetric. It doesn't matter which end you interact with. But from my mechanical perspective, this entanglement system is antisymmetric. It does depend on which end of the entanglement system you are interacting with. You get two different interaction outcomes: a rip or a warp. Quantum mechanics and general relativity. Okay, so this might sound really stupid, but quantum mechanics and general relativity, small and big, they're two things, okay? They're two things. So, we're trying to combine them, right? If quantum mechanics is half of the entanglement system, and classical mechanics is the other half of the entanglement system, then when you take one away, gravity, you literally only have a conformal field theory without gravity. But when you put gravity back together, then you have an entire entanglement system with anti-symmetrical ends. One interaction can add tension to the system, which, if you add enough tension, it'll rip the medium entirely. This is wave function collapse, just a discrete amount of energy in a localized space between the entangled system. The other interaction is continuous because you are removing tension, and so the medium doesn't break, it just warps. This warping is analogous to gravity and how mass warps the fabric of space-time. However, this is happening non-locally through the other half of the non-local interaction, which creates the warp in between the entangled system. This is a stable holographic desitter spacetime where the boundary is antisymmetric. Without both of them together, you don't get a bulk, okay? There's nothing. So you need to combine them literally. They are two halves of one system. And if you remove one, then the system collapses.